Hello. For the first part of this video, I'd like to say that I did finish the first part of the lab about building an Arduino from the separate components. But for my RC car, I'll be using an off-the-shelf model because it will be easier to work with. As you can see, this microcontroller has had a bootloader burned onto it, so it is not programmable. Hello. I'd like to demonstrate my RC car. My RC car is built with two Arduinos, two Bluetooth radios, an ultrasonic sensor, and an accelerometer. Basically, this first Arduino will take the measurement from this accelerometer, whether that be forward, backwards, left, or right, and then transmit that data through this Bluetooth radio. Over here, this Arduino will then read in that data from this Bluetooth radio. Once the Arduino has gotten the data and has determined what direction the controller is facing, it will then output the correct direction to this motor drive. The ultrasonic sensor will determine the distance to the nearest object. If the nearest object is within 10 inches, it will stop the car and only allow the car to move backwards. The Bluetooth radio has 5 pins, but for now only 2 are important, the RX and TX pins. The RX pin is for receiving and the TX pin is for sending. The other important component in my circuit would be the accelerometer. As the name implies, it measures acceleration. I use it to measure tilt, whether that be in any direction, which I then use to send information to the other Arduino, which then tells the RC car which direction to drive using motion control. In my circuit, I've implemented a voltage divider. That is because the RX pin accepts 3.3 volts, but the Arduino pin sends out 5 volts. So, the RX pin is connected between a 1000 ohm resistor and a 2000 ohm resistor, allowing for 3.3 volts. I also do the same on the RC car circuit. Underneath the car, I have a voltage supply made of 4 AA batteries, which is connected to this voltage regulator, which helps smoothen out the voltage output from the battery. There I have a switch, which is connected to the voltage supply before it reaches the rest of the car. When the switch is closed, it will allow the voltage to go across the car, but when the switch is open, it will not allow the voltage to go across the car, and thus turn the car off. I'll show the RC car moving around. Tilting the controller forwards, move the car forwards. Tilting the controller backwards, move the car in reverse. Tilting the controller to the right, move the car to the right. Tilting it to the left, move the car to the left. Here I would like to demonstrate how if the ultrasonic sensor detects an object within 10 inches, the car will only be allowed to move backwards. In this case, the closest object will be me. As you can see, I am tilting the controller forwards, but the car is not moving. The car will also print out stopped to the serial monitor. Now, once I move backwards, the car will move. I'd like to show the movement in more detail. When the controller is tilted to the left, the right wheel will turn, allowing the car to turn left. When it's tilted to the right, the left wheel will turn, allowing the car to turn to the right. Backwards, both wheels will turn. Backwards, of course. When it's tilted forward, it will go forward at a certain speed. When it's tilted even more, the car will go even faster. If you can hear a difference.